Bismillahirrahmanirrahim. Dear students, today we are going to discuss continuous function definition. A function f of x is said to be continuous at x is equal to c if the following three conditions are satisfied. F of x is defined at x equals to c. Let we have a function f of x equals to 2x minus 3 and x equals to c mean x equals to 2. So now put x equals to 2 here. F of 2 equals to 2 into 2 minus 3, 4 minus 3, 1, which is a real number, and similarly the 2 is also a real number. So it is defined at x is equal to c mean x is equals to 2. The function is defined. We will try the other number also. When a function become undefined at certain value, so then it will be not continuous. So this f of x is defined at any number. If we put any number 1, 2, 3, minus 1, minus 2, it can't be undefined. So that's why the first step we have done it. The second is the limit of f of x exists such that limit x approaches c or x tends to c or x goes to c, f of x exists. For this, as we have supposed that the c value is 2, so we are going to take limit x approaches to of f of x equals to limit x approaches to of 2x minus 3. Put the limit value here. 2 into 2 minus 3, we get 4 minus 3, 1. So the limit x tends to 2 f of x or x approaches to f of x also exists, which is 1 in real number. Now the third step is that the limit value of a function is equal to f of c. So look here, this is f of c, f of 2, and this is limit x tends to 2 f of x, so both are equal. Limit x tends to 2 or approaches to of f of x equals to f of 2. So the given function is continuous for all c belong to R. Now how will be the graph of continuous function? The graph of continuous function will be like this. There will be, look, there is there any gap or break or hole? No. So the graph of continuous function will be continuous. There will be no gap or hole or something. Let us suppose we have another graph like this. This function is not a continuous function because there is a break, and similarly this is also discontinuous because there is a hole. So a function which is not continuous is called discontinuous function. Now come to the exercise question. Come to the question number 5. In question number 5, part A, f of x equals to 2x minus 3. So we will check that it is continuous or not continuous or discontinuous. We have already shown this in the definition, this one, that it is continuous. But now if it comes in the paper, how we will solve it? We will solve it generally. x equals to a belong to real number. So the first condition is we will find f of a. 2a minus 3 which equals to 2a minus 3, and 2a minus 3 is also a real number. It is defined. Put the a value 1, 2, 3, anyone, it is defined. The second condition is take the limit x approaches a of f of x equals to, we can write it as limit x approaches a 2 of x minus 3 which equals to 2a minus 3. This also belong to R. Now look, f of a third, limit x approaches a f of x equals to f of a, both value are the same, so the given function is continuous for all a belong to real number. Similarly, part second one, b, g of x equals to 3 minus 5x, let x equals to a, so g of a equals to 3 minus 5a. It is defined. This is also a real number, belongs to real. And now the second, limit x approaches a of g of x equals to limit x approaches a 3 minus 5x which equals to 3 minus 5a belongs to R. It also exists, and g of a equals to limit x approaches a, g of x, both have the same value, so the given function is continuous. Now look, part C, h of x equals to 2 divided by x minus 5. Now look, if we put here the x value 5, 2 divided by 5 minus 5, 2 divided by 0, which is undefined. So the function is discontinuous at x equals to 5. The function is discontinuous at x equals to 5, and it is continuous for all other numbers, but it is discontinuous at this. So we will just write that point on which it is discontinuous. When we show a function discontinuous, then there is no need to prove it that it is continuous at all other points. Similarly, the next one, g of x equals to x minus 5 over x minus 3 into x plus 2. Now look, put x equals to 3, so we get g of 3 equals to 3 minus 5 over 3 minus 3, 3 plus 2 we get 3 minus 5 we get minus 2 over 0 into 5 we get minus 2 over 0, which is undefined. So the function is discontinuous at x equals to 3. Similarly, when we put x equals to minus 2, again the function is discontinuous, it is not defined. So the function is discontinuous at x equals to 3 and x equals to minus 2, and is continuous for all other values of x. Now look at part F, which is f of x equals to 1 over x into x plus 7. If you put x equals to 0, so here f of 0, 1 over 0 into 0 plus 7, so we get 1 over 0 undefined. And if you put x equals to minus 7, so f of minus 7 equals to 1 over minus 7 into minus 7 plus 7, 1 over minus 7 into 0, 1 over 0 again it is undefined. So the given function is discontinuous at the given function is at x equals to 0. Look here, x equals to 0 and x equals to minus 7.